Hey guys, I'm here today to offer you with a little information about the atomic line spectra. Okay, so you might be asking yourself, what is the atomic line spectra? And the book defines this as the emission or absorption of light only at discrete wavelengths. Now this is a pretty vague definition in my opinion, so let's break it down. When atoms become excited, they emit different wavelengths of light, which correspond to different colors of light, and these colors fall within the visible light spectrum. When an atom becomes excited, it moves from its ground state in its original orbital and the energy level to its excited state in an orbital farther away from the nucleus with a higher energy level. The light that is emitted by these atoms can be observed through a series of discrete colored lines that are produced by these wavelengths. Each element has its own unique set of lines. Now, how are these lines formed? They form as atoms move from a negative electrode to a positive electrode while colliding with gas particles. These collisions lead to the emission of light, which is then separated through a prism and the visible light spectra is produced. Now let's talk about the Balmer series, which is just the spectral emission lines of the hydrogen atom. This is a result of electrons moving from higher orbitals with more energy to lower orbitals with less energy. Each transition from orbital has its own specific name and wavelength. The series of lines are found within the visible and ultraviolet region of visible light spectrum. Lastly, we will leave with the Rydberg equation. The Rydberg equation is a formula used to predict the wavelength of light resulting from an electron moving between energy levels of an atom. When an electron changes from one atomic orbital to another, the electron's energy changes.